Question number 1. It says let x1, x2 up to x50 is IID Poisson 5. Okay. So you have 50 IID samples from a Poisson distribution with parameter 5. Okay. Let's write it down. So we have x1, x2 up to x50 IID Poisson 5. Right. Now we are taking another random variable y, that is sum of all these random variable x1, x2 up to x50. The first question that is asked is what is expected value of y? Okay. So how is y defined? It is x1 plus x2 plus up to x50. And since we know that expectation follows the linearity property, it can be written as expected value of x1 plus expected value of x2 plus up to expected value of x50, right? And since each of these random variables x1, x2 up to x50 are coming from the Poisson 5, then expected value of each of these random variable are going to be same, right? We know that if, let's say, if you have a random variable x that is Poisson lambda, then its expected value is given as lambda, right? So here also it will be the parameter lambda for each of these random variable. It is going to be 50 times 5, that is 250. So the expected value of y is 250. Now the second problem is what is variance of y? Again, y can be written as x1 plus x2 plus up to x50. Okay. Now we know that all these xi's are independent to each other. Since they are independent, we are able to write this as variance of x1 plus variance of x2 plus up to variance of x50. Now we also know that variance of the random variable x is also lambda. Okay, so this is going to be 50 times lambda, that is 5, that is 250. So both the expected value and the variance is going to be 250 for y. Let's look at the third part. It says here you have to find what is the probability that mod of y is greater than 100. We have to use the normal approximation and express your answer in terms of fz. Okay. Now this can be written as, this mod of y greater than 100 can be written as probability y greater than 100 plus probability y less than minus 100. Okay. We know that y is a random variable that is defined as x1 plus x2 plus up to x50, whose expected value is 250 and variance also is 250. Now to convert this y to the standard normal form, we will have to subtract its mean from y and divide by its standard deviation. We'll do here probability y minus 250 divided by under root of 250 greater than 100 minus 250 divided by under root of 250 plus probability y minus 250 divided by under root of 250 less than minus 100 minus 250 divided by under root of 250. Okay. This y minus 250 divided by under root of 250, this becomes z, right? This z is greater than minus 150 divided by root 250 plus probability z less than minus of 350 divided by root 250. Now this first expression can be written as 1 minus fc of minus 150 divided by under root of 250 plus fc of minus 350 divided by under root of 250. So the correct answer is option C.